Question number 19 is, a child has a die whose 6 faces show the letters as given below. So you can see first one is A, then B, C, D, E and E. A. Okay. So you can see that A is coming twice, remaining else B, C, D, E all are occurring only once. And what is given? The die is thrown once. What is the probability of getting first one A, second one D? So when you say that what will be the total possible outcomes, total number of possible outcomes will be 6. 1, 2, 3, 4, 5, 6. Now the first subdivision is you have to find out the probability of getting an A. So P of getting A will be same as number of favorable outcomes of getting A, or you can say number of times A occurs divided by A occurs divided by the total number of outcomes. So what you will get, number of times A occurs is 2 divided by the total number is 6, so it is 1 by 3. Now what is the second one? Probability of getting a D. How many D's are there? Only one. So we will say probability of getting D is equal to number of times D occurs divided by the total number of outcomes. You will get 1 by 6. Okay. Question number 20 is, suppose you drop a die at random on the rectangular region shown in the figure below. What is the probability that it will land inside the circle with diameter 1 meter? So how will you do this problem is, the total outcome will be not in numbers, it is actually the area. Again, the possible or favorable outcome is the circle, that means the area of the circle. Okay, so the total outcome is equal to area of rectangle, which is 3 into 2. Okay, so you will get 6 meters square as the area of the rectangle, and that will act as the total outcome. Now the favorable outcome means it will be the area of the circle. What is the favorable thing? That is it should land inside the circle. Okay, the die should land inside the circle. So the favorable outcome will act as the area of the circle, which diameter is given to be 1 meter. So what will be the radius? 1 by 2 meter. And you can use the formula as pi r square. So pi into what is r? Half square, which is equal to pi into 1 by 4 or pi by 4 meter square. So that is the favorable outcome. Therefore, the probability of that it will landing the die inside the circle is equal to favorable outcome, which is pi by 4, divided by total outcome, which is 6. So we will get pi by 24 as the probability. Okay. Question number 21 is, a lot consists of 144 ball pens, of which 20 are defective and the others are good. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? She will not buy it. So here it is said that she will buy the pen if it is non-defective or good pen, and she will not buy it if it is defective. So what we need to do is, the total number of outcomes, possible outcomes, or you can say total number of ball pens, is equal to 144 and 20 are defective, and given as number of defective pens is equal to 20. Therefore, number of non-defective pens or good pens is equal to 144 minus 20, which is 124. Now what we need to get? The shopkeeper draws a pen at random and gives it to her. Now she will buy it if it is a good pen. So what will be the probability of getting a good pen? Okay, therefore the first one, that is P of, that is she will buy it, is same as P of getting a good one. What is that? Number of good ones divided by the total number of pens. So it is 124 by 144, which is 31 by 36. When you cut it, you will get 31 and 36. Okay, so this is the probability of getting good pen, or that she will buy it. Now what will be the probability that she will not buy the pen? She will not buy it, that is the pen. That means probability of getting a defective one, right? So you have two things. Either you can just make it as 1 minus probability of getting a good one, or you can just take the number of defective pens divided by the total number of pens. Okay. It is equal to P of getting a defective pen, or which is same as 20 by 144, or you can say that it is equal to 1 minus P of getting a good pen, which is 1 minus 31 by 36, which will give you 36 minus 31 by 36, which is 5 by 36. So this is one way, or this you can follow, which is same as 5 by 36 also. So either of the method you can use. Okay. Question number 22 is, two dice, one blue and one grey, are thrown at the same time. Complete the following table. So the table is given in which the event is sum on two dice. So the minimum sum which the two dice can have, that is sum of the two dice can have, is 1 and 1 coming on each die. That will be 1 plus 1, 2. And the maximum which they can have as the sum is 6 and 6 coming on both the dice, and that will give you the sum as 12. So these are the cases, that is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and for each of them we have to find out the probability. Some of the probabilities are given, that is when the sum is 2, 1 by 36, when the sum is 8, 5 by 36, and when the sum is 12, 1 by 36 is given. Remaining we have to find out. So for the first thing which you should know is, what are the possible outcomes when you throw two dice. So these are the possible outcomes, that is 1, 1, 1, 2, 1, 3, etc. 1, 6, 2, 1, 2, 2, etc. 2, 6, etc. from 6, 1, etc. till 6, 6. That means altogether you have how many total outcomes? Total number of outcomes will be 36, that is 6 into 6. Here you have 6, here you have 6, so 6 by 6, which is 6 by 6 is like this. Okay, 6 by 6 is 36, or 6 square is 36. So now what we need to do is, we have to find out the probability of each of the case when the sum is 2, 3, 4, 5, 6, like that. Okay, so we'll start with what is given, probability of getting a sum, getting the sum as 2. Okay, getting the sum 2, that is given already. Now how we are getting, just see here, this is the case where you are getting the sum as 2. So you have only one option. So that's why it is number of possible, or number of favorable outcomes divided by total number of outcomes, which is 1 by 36. Okay, that is given. Now how will we find out probability of getting the sum as 3? Again, moving on to this one, 1, 2 and 2, 1 are the cases in which you will get the sum as 3. That means these two. So you will have the number of favorable cases is 2 divided by the total outcome is 36. So 2 by 36 is the probability of getting a sum as 3. So it is 2 by 36, we have filled it. Okay. Now next is probability of getting the sum as 4. Again for 4, we will move here. 1, 3, 2, 2 and 3, 1 will give you the sum as 4. That is 1 plus 3, 2 plus 2 and 3 plus 1. So these 3 are the cases, that is favorable cases. So you will have favorable cases divided by total number of cases. So it is 3 by 36. 3 by 36. Next is probability of getting the sum as 5, which is equal to, here you have 1, 4, 2, 3, 3, 2 and 4, 1, all will give you the sum as 5. So you have 1, 2, 3, 4. 4 favorable outcomes and the total outcome which is 36. So it is 4 by 36. Next is probability of getting the sum as 6. As 6 means you will get 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2 and 5 plus 1 as getting the sum as 6. So these are the possible or favorable outcomes. Now how many are there? 1, 2, 3, 4, 5. So you have 5 divided by 36 as the probability. 5 by 36. Now probability of getting the sum as 7 will be again 1, 6, 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2 and 6 plus 1 all will give you the sum as 7. So these are the elements which you are getting as the sum as 7. So you have 1, 2, 3, 4, 5, 6. So it is 6 by 36. 6 by 36 as the probability of getting a sum as 7. Next is given actually, that is probability of getting a sum as 8 is given, which is 5 by 36. So we will just see which are those: 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2. 1, 2, 3, 4, 5. So these are the 5 outcomes which will give you the sum as 8. So getting the sum as 8 is already given, which is 5 by 36. Okay, next is probability of getting the sum 9. The sum as 9 means you will get 1, 2, 3, 4. That is 3 plus 6, 4 plus 5, 5 plus 4 and 6 plus 3 will give you the sum as 9. So you have actually 4 by 36 here. 4 by 36. Next one is probability of getting the sum as 10. So let's see, 4 plus 6, 5 plus 5 and 6 plus 4 will give you the sum as 10, these 3 elements. So you will have 3 by 36 as the probability of getting a sum 10. Next is probability of getting the sum as 11. Again you can just see 5 plus 6 and 6 plus 5 will give you the sum as 11. So you have 2 outcomes, possible outcomes are 2 and the total number of outcomes 36. So it is 2 by 36. And the last one, which is already given in the question, that is probability of getting the sum as 12 will be, you can just see it is 6 plus 6, only one option you have, so it is 1 by 36. Okay, so these are the probabilities of the respective sums. Now the second part of the problem is, a student argues that there are 11 possible outcomes, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore each of them has a probability 1 by 11. So since they are 11 in number, the child or the student is arguing that each should have equal chance to occur, that is the probability should be equal for each of them. So do you agree with this argument? And if you agree or if you don't agree, justify your answer. You have to give reason why. So the thing is clear from the table itself. The table is giving you the probability values differently, that means it is clear that each is not getting the value 1 by 11, and the reason is the occurrence of these events is not equally likely. So you can just say for the answer it is no, we don't agree with the argument. Now what is the reason? Since the events are not equally likely. When they are equally likely, then only they will have equal probabilities also. So since the events are not equally likely, the probabilities are also not equal. Okay, and hence the probabilities are also different, that is they are not equal to 1 by 11, even if they are 11 in number. Total possible outcomes are 11, but they don't have equal probabilities. Okay. Question number 23 is, a game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So first thing which we should know is, if a 1 rupee coin is tossed 3 times, that is same as tossing 3 coins simultaneously at a time. Okay, so here they have given that you have only 1 coin and that is been tossed 3 times. So again the result or the outcomes will be same as tossing 3 coins simultaneously. So what are the total possible outcomes? The possible outcomes for this experiment are getting all the 3 as heads, then 2 head and 1 tail, and that will come in 3 ways, that is HHT or HTH or THH. Then getting 1 head and 2 tails, again that will come in 3 ways, that is 1 head and 2 tail can come like THT as well as TTH, and the last is getting all the tails, or you can say 0 head. So altogether you have 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes when you throw or toss a rupee or 1 rupee coin 3 times or 3 coins at a time. Okay. So now what we need is the total number of outcomes. Therefore, the total number of possible outcomes is equal to 8. Okay. Now what is given? Hanif will win if all the tosses give the same result, that is if the Hanif is getting HHH or TTT, then only he will win the game. Otherwise he is losing the game. So we have to find out the probability that when he will lose the game, that means when the outcomes are these 6 except HHH and TTT. Okay, so the favorable outcomes, or you can say Hanif will lose the game. Favorable outcome, or Hanif will lose the game when you will have the outcomes as H, T, H, 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 T, T, H, 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 T, 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 H, T and TTH. I think no repetition. So 2 head 3 cases, 2 tail 3 cases. Okay, so altogether you have the number of favorable cases or number of favorable outcomes are 6. Therefore, the probability of Hanif losing the game will be equal to favorable outcomes number divided by total possible outcomes number. So it is 6 by 8 or 3 by 4. Okay. Question number 24 is, a die is thrown twice. What is the probability that first one 5 will not come up either time, second one 5 will come up at least once. So again, die is thrown twice means you will have these outcomes, or it is same as throwing 2 dice simultaneously. Okay, so 1 1 1 2 etc. 1 6 2 1 etc. 6 1 6 2 etc. 6 6 are the total possible outcomes. That means you can write the total number of possible outcomes. Total number of possible outcomes is equal to 36. Okay, now what we need is the probability in which 5 will not come up on either time. Either time means you can have in one of the thing or in both. That means these are the 1 5 2 5 3 5 4 5 5 5 6 5 5 1 5 2 5 3 5 4 5 5 already taken, 5 6. So how many favorable outcomes you have in which you will get 5? That is 1 2 3 4 5 6 7 8 9 10 11. Okay, so the favorable cases or favorable outcomes in which, so which one we are taking the favorable case, that we have to mention, because here they have not given which should be mentioned. Okay, in both the questions you have separate or opposite things. So we are mentioning favorable outcomes in which 5 will appear. Okay, in which 5 comes up in, that is all the cases. Okay, comes up will give you, they are, it can be 1 5 2 5 3 5 4 5 5 5 6 5 5 1 5 2. You can just see it's opposite of this one, 1 5 then 5 1. Okay, 5 1 5 2 5 3 5 4 5 5 already taken, so 5 6. So these are the favorable outcomes in which you have 5. Therefore the number of outcomes or favorable outcomes in which 5 comes up is equal to 11. Okay, so now we will go to the question. What is the question? In which 5 will not come up either time. Okay, in any of the times 5 should not come. So all these will be included in 5 means rest of them will be in not coming up. That means therefore the number of outcomes in which 5 doesn't come up. How will you find out? Total outcomes is 36. From that, if you subtract these 11, you will get the remaining as the total outcomes in which 5 is not appearing. Okay, so it is 36 minus 11, which will give you 25. So this is the number of, and you have to find out the probability. Therefore, what will be the probability? Probability that 5 will not come up either time will be equal to 25 divided by 36. Okay, now what is the second part? So this is your first part. What is the second part? Probability that 5 will come up at least once. So these are the cases in which 5 will come up at least once. So minimum 1, and to the maximum it can have 2. So at least 1 means 1 and 2, that is 1 time 5 coming up and 2 times 5 coming up. Okay, so altogether these are those things in which 5 will come up at least once. So the number of outcomes already you have written, so we can directly do that. Probability of 5 will come up at least once will be equal to the number of outcomes in which 5 comes up, that is 11, divided by 36. Now if this is not okay for you, you can just go for the other thing, that is 1 minus P of 5 will not come will give you the same answer, that is 1 minus 25 by 36 is also giving you 11 by 36. So both concept is okay. Okay, which one is clear for you, that you can use. 25th question is, which of the following arguments are correct and which are not correct? Give reason for your answer. So the first subdivision is, if 2 coins are tossed simultaneously, there are 3 possible outcomes. 2 heads, 2 tails, or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3. This is what the argument is. We have to say whether this argument is correct or not. When two coins are tossed, what are the possible outcomes for the first one? The possible outcomes are getting 2 head, getting 2 tail, getting 1 head, 1 tail. That is, in the first toss you are getting first head, then second one giving you tail, and 2 coins are tossed. So one is giving you head, the other one is giving you tail. The first one is giving you tail, second one is giving you head. So these are the possible outcomes. That means you have total number of possible outcomes is equal to 4, right? Now when you go for what is the probability of getting 2 heads, what they are saying, the probability of each should be 1 by 3 is their argument. So we are just seeing what will be the probability of each one. So probability of getting 2 head is this one. You have number of possible favorable outcomes as only 1. So the probability will be 1 by total possible, which is 4. Okay, the probability of getting 2 heads is 1 by 4. Now what is probability of getting 2 tails? It is again 1 out of the 4, so it is 1 by 4. Now what is the probability of getting 1 head and 1 tail? 1 head and 1 tail. So we have actually 2 things which are giving you 1 head and 1 tail. The order is different, but they are giving you 1 head and 1 tail. That means you have 2 out of 4 giving you 1 head and 1 tail. So the probability is 2 by 4, which is 1 by 2. That means you are getting the probability like 1 by 4, 1 by 4 and 1 by 2. And they were saying that the probability should be 1 by 3 each. Therefore, their argument is incorrect. Okay. Now what about the second one? In the second one, if a die is thrown, there are 2 possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number should be 1 by 2. This is the argument. So let's see what is for the second one giving you. If a die is thrown, what are the possible outcomes? The possible outcomes will be 1, 2, 3, 4, 5, 6, right? Possible outcomes are 1, 2, 3, 4, 5, 6. That means the total number of outcomes are 6. Therefore, the number of possible outcomes is equal to 6. Now what we need to find out is the odd numbers and even numbers as taking as the event and what is their probability, right? So what will be the probability of getting an odd number? Probability of getting an odd number will be total number of odd numbers, which are 1, 3 and 5. That means 3 divided by the total possible outcomes, that is 6. So you are getting 3 by 6, which is 1 by 2. And P of getting an even number is equal to, again you have 2, 4 and 6 as the even numbers, so that is also 3 in number. So 3 by 6, which is again 1 by 2. So the probability of getting an odd number is 1 by 2 is correct. Therefore, the argument in the second case is correct. Argument is correct. What they are saying is absolutely right. Okay.